For number 1, you needed to put 3 in for all of your x's. So 2 times 3 plus 1 over 4 minus 3, which would give us 6 plus 1 over 4 minus 1, 7 over 1 over 7. Seven should have been your answer for that one. For number 2, was this relation a function?
No.
No. This would not be a function. For number 3, what would be the equation of this line? Y equals 4x minus 9. It gave you the slope and the line-intercept. You just had to put them both in the slope-intercept form. Questions on any of these 3? For number 4, what is the equation of this line? It was shifted down 3. I know this is not something we talked about in this class, but if we wanted to shift this down 3, we're really just looking at the y-intercept and moving it down 3. The slope would not change, so whatever your slope is would stay the same. Negative. And then instead of plus 4, because we're moving it down 3, this would now be at positive 1. And then number 5, we had to graph the equation, so starting at negative positive 2, going up 3 to the left 1, and then down 3 to the right 1. Really close to this question though. And I don't know the exact date. May is all I know.
May. That's very broad.
I know it's going to be like the first couple of weeks. I don't know the exact date yet. As soon as I know that, you guys will know that. Yeah.
Now, when are we going to take the cash out?
Sometime after the SOL. So it'll be, we take the SOL, and then after that, it'll be like review day, test day, review day, test day. And then we'll get through the next unit as well before the SOL. Questions on these 2? Okay. Look at your course calendar. For this unit, we're going to be factoring. Some of you may know parts of those methods. Some of you may not when we get to certain things, and that's okay. And dividing polynomials. So part of that will be with factoring, part of that will be using your exponent rules. As you can see, the test dates are not on here, but that will be after the SOL. We are really just focusing on getting this information and then later testing. Also, recognize or look at the dates, because you do have confounding means due this Friday. Nothing due next week, obviously, because of spring break. And then some of the things that we talk about this week, those confounding means won't be due until the Friday we get back. Just make sure you are aware of those dates. Do you have any questions on the course calendar? Alright, so before we talk about actual factoring, let's do these problems right here. This should be good review from last unit. How would I solve this? Or simplify it?
VA squared.
I would distribute and multiply to get 3a squared. What was the second thing you said? Plus 7a. When we multiply 8 and 7. When we distribute the next 3, what would those give us? To the third power.
Yeah.
And then 12 squared. Be careful with this one because you'll find a lot of things. 4x to the third, y times x squared, what would that be?
4 minus 6y.
Not to the 6.
What?
5.
5. Sorry.
Y.
Y. Negative 2y.
Negative.
Negative 4x squared. Negative 8.
So when we factor by GCF, we're really doing the opposite. We're taking these things that we got over here, we're trying to get it back to this form. This is our factored form. I want you to write this part. This is the more formal definition of factoring. We're separating a polynomial, which is more than one term, could also be one term, back into a product. And I'm going to use this example to show you exactly how this works.
I personally really like to.
I
like
like
the steps.
factoring in general. It's like a puzzle. Like, what do I do?
Fun for you guys?
Like the only thing in math that I actually enjoy is polynomials.
I think I know who got 100 on the test.
Some people were close, but I don't think anyone did.
I mean, no one got 100? I knew it, you're smart. You want answers of it?
Okay, so I'm going to show how we would do this. When we are factoring, actually let me fill this out. So this, the one, the polynomials that cannot be factored are prime. What that really means is the only thing we can divide out of it is 1. And when we factor, our goal is to get our inside, you'll see what I mean by that in a second, to be factored. So when we look for a GCF, we're looking for the numbers first. We're looking for what do these two things have in common that we could divide out. Now, with some of these, they'll be really easy to look at and be like, I can divide out 2, I can divide out 4. Some of them, the numbers will get bigger, and you may need to look at all the numbers. We can do that just so that we have it. And then you'll see me do that later also. So I would list out the factors of 4, which are 2 and 4. And then the factors of 8, 4, 4 and 2 doesn't matter. And a lot of these you have to remember that you can divide itself out to.
How do you get 2 and 4 on one night?
What times what would you be?
4.
So then when you're looking for GCF, you're looking for the highest number these two share, which would be what? 4. This is usually just going to be one number. And then when we find that highest number, to factor out, we're dividing. But we're not actually dividing. It's weird. Because we don't want it to go away. We just want to recognize that we are dividing. So we put it on the outside of our answer. But we're also looking for how many variables they have. So these both have A's, right? But we don't have the same amount of A's. So we have to look at how many A's do they have in common, or the lowest amount of A's they share, or the highest amount of A's they share. Sorry. Could I say that these both have 2 A's? Because this one doesn't. So I couldn't take out A squared because they both don't have that. But they both have at least one A. This one has more than one, but that's okay. That would also be part of your GCF and part of what you divide, which is why there's a 4 and an 8 on the outside. So whatever that GCF is, you take it, you put it on the outside, and then you're dividing to see what's left. 4a squared divided by 4a, what would that give you? A. The 4's will cancel, and then you're using the exponent rules. Bases, so you're subtracting your exponents. 2 minus 1 would give you 1. Like, yes, because it wouldn't be fully factored.
Can we just use the same weekly rates to just like determine what it is like?
Some of them will be easy enough that we won't have to do this process every single time, and you'll just be able to quickly do it. But I'm just showing you the process. Okay, so this is how we got A first. And A divided by 4A is what?
2.
A's would cancel, because we have 1 minus 1, which is 0. The A's would just become 1 divided by 4 is 2. The inside of this, these don't have anything else in common. The only thing I have to divide out of A and 2 is 1. So that inside is not prime. So this is our final answer. Now, what questions do we have on that before we actually do some problems? Let's start with number 1. Ignore these numbers just for if you're doing the informative version of this. So for number 1, look at both of these. And if you're not sure, you can list out the factors just as we did before. So I'll do that for this one, but we won't do that for every single one. What are factors of 3? What are factors of 12? And 4 and 6 and 2 and of all of those factors, what is the highest number they share? 3. Do they share variables in common? No. No. One has an x, one doesn't. So that means our GCF is just 3. So that means we're going to divide both of these numbers by 3. But again, we're not actually, like we are dividing, but we're not getting rid of this 3. We want to still keep whatever this GCF is, so that's going to go outside of our parentheses. 3x divided by 3 would be what? 1x. And then 12 divided by 3?
4.
10 Can we divide anything else out of the inside
Yeah, but no.
besides 1?
Yeah.
Can we divide 4 out of both of these?
No, not each.
So 1 is the only thing we can divide out, so the inside is prime, so that is our final answer. You can go back and check yourself with these by distributing. So if I were to distribute this, I would get 3 times x, which is 3x, 3 times 4, which is 12. So I know that works. Divide out the 3. So you are dividing it to find the inside, but you also need it outside. Other questions on that one? With a lot of these, the lowest number is usually your DCF, but that's not always the case, so be careful with that. For number 2, what do these two have in common? That would be our DCF. They don't share a y, so we wouldn't put y. So if we're dividing both by 7, 7 is going to go on the outside, what would be left on the inside? So even if you divide it all out and it becomes 1, still put the 1. Don't not put that. That is still the number. Okay. Now for number 3, like I said before, it's usually the smallest number, but that's not always the case. Can I divide 36 by 8? No. So I need to think about what that factor would be. Again, you could do your factor tree, or you could just think about your factors, whichever one works best for you. You don't have to do this if you know your factors really well, but if you don't, that's okay.
So we do like 4.
4 would work. I'm still going to do this, but 4 would work. What are factors of 8?
4 and 2.
4 and 2. And 1 and 8. Factors of 36. 1 and 4.
And
12.
12.
So add some others. 26.
8 and
19. There's one more. 69. So when I find these factors, I usually go least to greatest. So I set 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. That way I see the difference between the numbers get smaller. And the smaller that difference is, I know there's no more. But again, if you get the highest right off the bat, you don't have to keep doing this. But it is a good check to make sure they don't have anything else in common. So 4 is our highest. Do these have variables in common?
No, we don't.
No, we don't. So we're going to divide both of these by 4. Now, I'm not writing that I'm dividing them both by 4, but we're still doing that. So if we're dividing 8n by 4, what would be left? 36n divided by 4? Can I take anything else out of this inside? That inside is fine, that's our final answer. You can distribute that back out and make sure it works. Save. Number 4. Looking at those numbers, could you tell me what the DCF is? 5. Do they have any variables in common? No. If we divide these both by 5, what would be left on the inside? X plus 6y. This part is, because there's nothing else we can divide out. So that would be our Do we have questions on this process so far?
No.
Let's jump around. Let's do number 6. For number 6, what is the highest number I can divide out of both of those? 4. Do they have anything in common? Anything else in common? They both have a y, and I can only use one y for both because this one doesn't have 2. So 4y would be my DCF. Now I'm going to divide both of those terms by 4y. What would be left?
Why?
Yes. That is fine. Y's in common. If we don't have variables in common, then we wouldn't do that. But if we do, then we need to include that every single time. For number 8, what number do you think we can divide out of both?
No. Yeah. No.
2.
2.
2. Sometimes the highest number isn't very high at all. Do you have anything else in common? Not both of them, but one of the h's, or I'm sorry, one of the variables can be taken out, the h, not the g. If we divide both of these by 2h, what's left? 7g minus 1. Number 9. What is the highest number we can divide out of both?
15.
5 works. 15 would be higher. So we're always looking for the highest, but I'm going to do this one as if we forgot about 15. So let's say we did 5. Do they have anything else in common?
Yes. Okay. You have A and B.
Yes.
The A has a square. A is 6.
One of them does have a square, but this one only has 1, so you can only take out 1. Again, this is not our DCF, but let's say this is the highest one we were thinking about, just so you see what happens. If I divide them both by 5ab, what would be left?
A.
Divide something else out of the inside.
Yeah.
What? This 3. So if I do that, I'm going to pull that 3 out and multiply it to whatever I have on the outside. If I divide these both by 3, what's left? And then actually multiply these together. So even if you don't get the highest GCF right off the bat, you can go back and get that later. But that would mean you have to be double checking to see, is this prime or not? If you're not checking that, you may miss that. So be careful with that.
So if you don't put the GCF, you take the undefined number, and then you put it outside next to the 5AB, and then you multiply that.
Mm-hmm. Yes. So you think about your exponents, rules, you can multiply these numbers together. All of these things are really being multiplied together. And you can't. If you don't get the highest GCF, it's okay as long as you get it eventually. Let's do number 10. What is the highest number you can divide out of both of those? 8 would be the highest, but if you didn't see that, you could do 4 and then you would just be doing the same process all over again. And these. Divide out 8BC, what's that? C. Plus. Then you may get some that don't have numbers at all. So like number 11. If it doesn't have numbers at all, the GCF would just be variables unless there aren't any. What do these have in common?
A.
So we divide A out of both. What's left? What would our GCF for 12 be? 1x, 1y. You can put the 1 in front, you don't have to. If we are dividing out x and y, what's that? For number 13, do you have anything in common? 1. So this is already fine because the only thing you could divide out is 1. So if you put that, and then I put 1 here, that wouldn't really change anything. So I wouldn't want you to do this because it doesn't do anything. We would just say this is 1. It's already in its factor form. Do you have a question?
Yes.
Not lose it. Remember, we're dividing this by xy, which is why it becomes this one. Number 15. Now there are 3 terms, but same rules still apply. What is the highest number we can divide out of each? 2. 2. And then how many variables or what variables can we take out? 1x and 1. When you start to get more terms, I would probably go back to writing it as a division problem just so you don't miss something. You don't have to do that, but if it helps you, I would do that. So if we divide out 2xy, what's left? What was that? That looks weird, but there's nothing else I can divide out of that inside. We don't have x's or y's or 2's in common, so that is prime. So that would be our answer. Questions on that one before we move on? For 18, because we have different numbers, 6 might work. But when you have more numbers, you may want to go back to doing your factor tree for each one. That way you can see your factors for everything. What are some factors of 12? 3. Factors of 36. And factors of 6. So the highest number these all share. 6. And for this, because 36 has 2 6s, it doesn't matter which one you circle. Do these have anything else in common?
Yeah, and
Divide each of these things by 6a squared b squared. Again, you don't have to write this, but if you do that. Well, a to the 5th b squared divided by 6a squared b squared would be what? The b squared is cancelled. Negative 36a to the 4th b to the 3rd over 6a squared b squared. And then negative 6a squared b squared over 6a squared b squared.
-1.
Now that looks like I should divide something else out, but there's nothing I can divide out. Not everything can be divided by 2. Not everything has A for B's. So that is your final answer. For number 21, what would our P4 be? M to the 2nd and M. M should we take out? 1. We're dividing each of these by MN. Battery full. To the squared, yes, the second power. And plus 5. Find them all. I think there was one. Now for this last one, we have a bunch of variables to be careful. Take it one step at a time. What's the highest number we can divide out of each of these? 3. How many A's, B's, and C's can we take out?
B2. 1A to 2B's and B2 and
3A, B squared, C. And I'm going to rewrite this so that I'm dividing each one. What's happening? Three A to the third B squared C is divided by 3A squared C. 3 what?
3A B squared C. A squared minus 3A B C.
That all for the first, I got lost.
No, you minus.
A squared minus 3.
Square C squared.
Now that really looks like we should factor it more, but there's nothing else we can do with that. You will have time to practice, but I want to show you this next rule, so we'll be able to do it really quickly. And then I'll pick out some problems where you can do it again. We're going to skip over the formula, but this would be going back to multiplying using FOIL or using the Gauss method. This is another way we factor using difference of squares. This is different than GCF, so don't think GCF for right now, we will later. But anytime we have something that's squared minus something that's squared, we're going to have an answer that looks something like this. We're going to have two sets of parentheses. These are going to be our factors. And we will take whatever the first term is, what times what would give me A squared. Okay, so I'm going to put A in both of those. What times what would give me B squared. B, I'm going to put that last in both of the parentheses. It doesn't matter, but you're going to have a plus, a minus, and 1. 1 and then the other. It doesn't matter the order. But this only works if these are perfect square terms, number or variable, and you're subtracting. If you're not subtracting, this is not. So for number 1, this is a perfect square term, 4 is a perfect square. Set up our parentheses. What times what would give you A squared? A. What times what would give you 4? 2. And then the plus and minus. And that's it. Now you can go back and check yourself by multiplying everything out. So A times A would give us A squared. A times negative 2 would give us negative 2A. 2 times A would give us 2A. And 2 times negative 2 would give us negative 4. These would cancel out. And we would get that same thing back. Yes, it should always be both the same. Or sometimes the order is switched. You won't always have the variables first. That doesn't matter. You just have to make sure the order you write them is the same. So what I mean by that is 81 is a perfect square, x squared is a perfect square. What times what would give us 81? 9. What times what would give us x squared? So instead of having the variable first, you would have the number first. Just whatever order it's in, make sure your answers are the same.
As long as it's more.
But if we do something like number 5, could we do that one? Because this does have a perfect square term, so does this, but this is adding. Because this is adding, this would be prime. Say it again. Adding is prime and doesn't. Some of these lower ones have more than just one thing. So like 7, same process, they just added more numbers. 4 times what gives you 9? 4 times what gives you b squared? And then what times what gives you 100? So you may have more added in there depending on what you're given, but you're doing the exact same thing. If you had something like 11, this, not really. What times what gives you 4? 2. What times what gives you 8 squared? 5. And what gives you 2 squared? Plus 5g and 2h minus 5g would be your answer. Yes. So as long as you can break them up, you're good. We're going to do just a couple more and then I'll give you time to practice. Alright. We're going to do 16 and 17. 4, 16, 49 and 16 are perfect squares. But now we have x to the 4th. This still works if your exponent is even. If it's not, then there's a different process to it. But if this is even, you can cut it in half. So what times what gives you 49? 7. If we split this in half, this would be m squared and m squared. And then what times what would give you 16? 7m squared minus 4 and 7m squared plus 4. Now, sometimes you will get answers that you have to factor even more. What I mean by that? Let's say this was something like you got these answers, but this was like 9 and 4. 9 is a perfect square, 4 is a perfect square. That means we could do this again. So if we got something like this, and these were our answers, we could take this one, because this is another difference of squares, and do this process again. Because then this would be 3 and m, and 2. And we would bring this one down as part of yours. So instead of just 2 answers, you might have 3. If you get something like this. That won't happen often, but it will happen. Yeah. bringing this one down? Because this is still part of our answer. We just also factor this in. So you reminded me. This is prime, so there's nothing else we can do with that. So we have to bring that down. This one we can factor more using differences. Taking what we just found out about exponents that are not just 2, what would our factors for 17 be?
K3.
Two to the third. And
4.
4 and plus 4. So when you ask for factors, these are your answers. K to the third minus 4 and K to the third plus 4. Those would be your factors, your final answers. Okay. Because I want you to have time to practice, we will do examples with the GCF and the other stuff in next class. I don't want you to do all of these, but I do want you to try some of them. I think we did all of them. So starting with GCF, I want you to try 7, 14, 16, 20, and 14, 16, 20. And then on difference of squares, let's do 4, 6, 8, and 12 on that first page. 4, 6, 8, 12. And then on the back, 19 and 20. There we go.
I'll even
So try this. Right, let's start with the GCF examples. 7, 14, 15, 20. Number 7 was 3b, and then in parentheses, 7c minus 1. Number, I keep forgetting. 14 was 6abc squared. Then in parentheses, 3a minus 8c. Six, yeah, 16, 3r, and then in parentheses, 3r to the 7th minus 6rs minus 8s. And 20, 16, and then on the inside, 3x squared y minus 4x z plus 6yz squared. Questions on those 4? This one. Number 4 for difference of squares was c plus 10, c minus 10. 6 was 1 plus 7y, 1 minus 7y. And the order does not matter. 8 was 5x plus 7, 5x minus 7. And 12 was 8u plus b, 8u minus b. Questions on those 4?
Number 6.
Was 11r to the third plus 1 and 11r to the third minus 1. 20 was 8m squared plus 3m and 8m squared minus 3m. Questions on either of those? So next class we will continue those examples and start with our next set of factoring. Make sure that you do your stuff now. You can start your Khan Academy if you need help with any of those. Continue after school today.